This presentation is an overview of Scala for Java development teams. It's broken into two parts. The first part is about 10 minutes of background information for people who are unfamiliar with the Scala ecosystem. The second part is comprised of a couple of live demos, the first one being a very simple application written first in Java and then in Scala that lets us compare the two languages. The second live demo is a very brief introduction to the Play web application framework. If you want to find this presentation so that you can go through the links that I've collected here, just Google Prezi, that's P-R-E-Z-I, and Overview of Scala for Java Dev, and that should take you to the presentation. Let's get started. To begin with, Scala is a multi-paradigm language. For people coming from Java, they'll find very familiar object-oriented capabilities, with classes and objects in a traditional type hierarchy, but they'll also find great innovations like case classes that allow us to write more concise object-oriented programs. In addition, Scala brings functional programming into the mix, with support for higher-order functions, pattern matching, and a great collections library. Higher-order functions are functions that take other functions as arguments. Pattern matching is like case statements on steroids. It's a really powerful feature, and the collections library supports higher-order functions on all the collections and provides both mutable and immutable forms of each of the basic collection types. So you're probably wondering, where does Scala come from? The principal author of Scala is Martin Odersky, and among his Java accomplishments, he's built the current generation of the Java compiler. He's also the author of generics in Java, and he's currently a professor at EPFL in Switzerland. Scala development actually began back in 2001, and it's been in production for a few years at Twitter and LinkedIn. Additionally, Foursquare, Tumblr, and lots more of startups are adopting Scala for its ability to build large, distributed, reliable applications. So what does the runtime and toolchain look like? By default, Scala compiles down to the JVM bytecode, which gives it great interoperability with the Java language. So all those familiar Java libraries you can still use. If you have an application already written in Java, you can start mixing in Scala. So it doesn't force you into an all-or-nothing adoption of a new language. Rather, you can start to apply it in little bits and pieces, enhancing your existing tools. Additionally, because Scala is a language in its own right, compilers have been built for target other environments, like the CLR for the .NET framework, or the low-level virtual machine toolkit that comes with a Clang C compiler, or even down to JavaScript. As far as the tool chain goes, one of the things that I really enjoyed as I adopted the language was the existence of the read, evaluate, print loop that really facilitates interacting and exploring the language. Additionally, there's support for Eclipse, IntelliJ, NetBeans, and even Emacs for diehards like myself. As far as the build tools go, Maven's supported through a Maven plugin, and there's a great new tool called the Simple Build tool that's written in Scala itself that lets you get up and running very quickly and provides enhanced functionality with regards to interactivity and other things from the Scala ecosystem. So either way, you can build it with Maven, you can build your applications with Maven or SBT, and both of them support mixed projects of Scala and Java. Let's look at some resources that I've collected for you to explore after the presentation. If you're looking for the main website for the language, you can find it at scalalang.org. If you don't know about Twitter's Scala School, you really should check it out. It's about 12 lessons that Twitter has put together to bring their new hire engineers up to speed on the language. Additionally, I've included links for JetBrains for the IntelliJ plugin, the Scala IDE, which is support for Eclipse, and TypeSafe, which is a commercial organization that provides consulting, training, and more for the Scala language, and several important libraries. Finally, if you don't know about it, you really should check out the Coursera course, and I believe I spelt that wrong. Not sure. And it's about it's functional programming in Scala that's presented by Professor Odersky. It's a great course. I really recommend it if you're unfamiliar with functional programming techniques. If you want to compare Java and Scala, I've also collected up some links. The first one is at InfoQ, and it compares myths and facts about Scala and Java. The second one is a comparison of Java 8 features in Scala. If you're thinking, well, maybe the Java language is catching up to what Scala offers, this might shed some light on that. The third link here was actually the inspiration for the simple program that we'll explore in the first live demo. And finally, you should know about Google's comparison of C++, Java, Scala, and Go. Scala did very well in the comparison, and I'll let you read the paper yourself. Finally, before we jump into the live demos, let's look at some important frameworks. The first one is Akka. Akka is a framework whose goal is to help you build highly concurrent, distributed, and fault-tolerant systems. It's actor-based, so you really can see some inspiration from Erlang in it. It has high-performance actors and advanced distributed computing facilities that help you build applications in that let-it-crash way that Erlang does, with supervisors and dispatchers, routing. It supports clusters, currently has a strong focus on elastic computing as well. The remoting support is great, with support for protobuf, 0MQ, and integration with Camel. If you're not familiar with Camel, it's an Apache project that helps you integrate to just about anything, whether it's AMQP or JMS servers, or FTP or even email. And finally, Akka also includes some higher order features in its own right, like the event bus. You really should check it out at akka.io. The Play Web framework is focused on helping us build reactive web applications. Translation there is there's lots of support for asynchronicity. In fact, the Play Web framework is built on top of the Akka framework. You should know that both of these frameworks support programming in both Scala and Java, and the Play Web framework supports OAuth and OpenID. And it has a wonderful hit refresh workflow. You'll see in one of the live demos that we can just change our code, and we don't have to go out and compile it and assemble it into some application archive or anything like that. It's just running the whole time. And that's one of the things that comes from SBT, that simple build tool that I was referring to earlier. It also has great support, testing support. Finally, there are other interesting libraries. Both Twitter and LinkedIn are contributing significantly to the open source environment. You've got the beginning links, the head links, if you will, here for Twitter's open source and LinkedIn's open source repositories. A couple of the libraries you should know about from Twitter are Finagle, which helps you build distributed applications in a reliable fashion. Ostrich, which helps you with server configuration, stats, and control. One of the contributions from LinkedIn is Kafka, which is a high-scale distributed pub subsystem. And finally, Netflix is also starting to experiment with Scala and publishing some things like RX. As you look at our RX, though, be sure to go look at iteratees that show up in the Play Web framework. Very interesting tool for doing asynchronous things and composing them in a functional way. Alright, let's dive in to our first live demo. And what we're going to do is compare a very simple application. The application defines a simple person class with a first name, last name, and age, and of course, because we want to put it in collections, a hash code and equals. And the goal of the application is to print a list of these people, these persons, who are older than 18, and print their first names sorted. Very simple application. I've put this code up in GitHub so that you can grab it yourself and play with it. And so let's use Git to grab it. Okay. If you're not familiar with Git, it's a wonderful tool for working with open source. Branching is wonderful, and great support. I'm going to start this building because it's the first time that I've run this application. You can see I've just dragged it down from Git source, so there's nothing here. I'm going to start everything from scratch. I have links in the presentation that I'll point to later on that show you how you can download SBT. SBT is just a Java jar file, and yet it's smart enough to do the sorts of thing we're doing. Start with a project definition, pull down the version of Scala that you need, build it, and then support interactivity. It's a great tool, very concise, that brings new levels of interactivity to some of the things you might want to do. In fact, it's your gateway into the Scala REPL these days. It's one of the ways in, and is a great way because it lets you pull in all the dependencies of the project as well. But we're not going to demonstrate that this time. Right now, we're just going to look at our very simple application. We'll watch it run first, and then we'll dive into the source code. So first, let's run the Java application. You can see it compiled both the Java and the Scala versions. Let's run the Java version first. You can see John old enough and John plenty old enough. In this universe, everyone's named John. And now we'll try running it. We'll run the Scala version. Same results. It's a little bit different because in one I return an array and the other one I returned a list. Now let's go look at the source code. And we will go down into the lab and my live demo, and we will look at the source for this project. Let's start with the Java source. And we'll begin by looking at our very simple value object. It's exactly what you would expect. There are private fields for first name, last name, and age. There's a constructor that takes those arguments. We have getters for each of those fields. And we have a very simple method that returns a Boolean, true or false, about whether the person's age is greater than 18 or not. In addition, because we want to put it in collections, and this is something you should do for all your value objects, of course, is we have a hash code and an equals that we can use for comparison. Now let's go look at the application that's going to use that. So we have a Java application with a static void main, of course, that begins by creating a list, the input list, adding 3 people into it. Turns out that I've used valid, invalid, and valid as their last names. And I've included initials, if you will, in their first name, just so that it makes it easier when we're looking at the output, so that we can see that we've gotten the results we expect. You can see that John T.Y., whose last name is invalid, is actually 17, so he shouldn't show up in our lists. The next thing we do is we run this input list through the valid by age method. We'll look at it in a second, and then just print that result. The valid by age method is pretty simple as well. It takes an input list of person objects. It makes a new type that we're going to use for returning. It makes a new type that we're going to use for filtering and sorting. A new instance of a collection, I should say, not a new type, but you can see the type here. And so we begin by filtering, right? So we just add to our people list those who are old enough. And then we run this through a collection comparator. In our normal fashion in Java. And finally we add just those people to our return list. We're going to make a new type. We're going to add just the first names of all of those people. And we've already seen it run. Now let's go look at what it takes to deliver that same functionality in Scala. This time it's all contained in one class. You can see our case class person here. In fact, one of the things you might notice is that we can put more than one class in a single file in Scala. And one of the things I referred to earlier about case classes is illustrated right here. By putting case in front of it, we get a hash code and an equals automatically defined for us. We get setters and getters automatically defined for us. We get a constructor automatically defined for us. So we get lots of things that help us just remove the boilerplate capability that we have to reproduce again and again in Java. And one of the reasons for that is the really strong type inference in support there is in Scala. You can see this almost looks like a dynamic language, the way that we're not having to declare types all over the place. The next part of our application is it extends the app trait. And here you see us making a value from this list of people, persons, the same list as before. We define our function here The syntax is different for defining methods because it's contained in an object here. So, one of the important distinctions between methods and functions is just where they're defined. And in Scala, the types are after the argument here defined. And so you can see we have a list of person objects, and we're going to run that through a filter. And here's our higher order function in place that is in one of the collections. So two of the strengths I referred to earlier. This time we've got a function literal. That's the form of a function literal that's saying that for each element in the collection, we have a p argument that we're passing into the filter function, and we're just going to run the valid method on it. And after that, we're going to apply in a fluent fashion, is what it's called in other languages. By just using a dot, we're going to sort by, this time, by the age. And finally, we're going to apply this very general function, a map. You've probably heard of map and reduce in frameworks like Hadoop. Well, Scala supports map and reduce right in the collections library. So here we are applying a map. And a map is a very generic function that lets us return new types. So while we have a list of persons here, the result we're going to get back is actually a list of strings for the first age, or for the first name. And to call all this, all we have to do is call println, valid by age, person list, and we're done. As far as the conciseness is concerned, I think I counted the Java application at about 101 lines. The Scala application, I think, is about 15. So we've got nearly a 7-to-1 ratio in terms of lines of code. I believe the Scala one is much easier to comprehend. You can see it all at once in front of you. The language, although concise, is very readable. So now let's jump back to our presentation, and we will go to our next live demo, which is actually a series of live demos that are all illustrating capabilities of the Play web application framework. Once again, I've put it in GitHub, so let's go to GitHub real quick. We'll just grab this little teaser, and I call it a teaser. Let's see if I can type and talk at the same time. Oops. You know, I pulled this down before, and I'm going to make sure that I remove it so that we can go ahead and get a clean copy here. We'll get a clean copy and we'll just start from the beginning. Okay, so I'll go down to the play teaser, and I call it a teaser because really it's such a brief introduction. This is no intention here of giving a proper introduction to Play, if you will, but rather just show you some interesting features and show how it builds from something very simple into some interesting things that we can do with asynchronous programming and working with JSON. So Play, this console that we're using right now, is built on top of SBT, so it takes SBT and extends it. It is also loading the project definition, doing its first compile, and this time I'm going to say to go ahead and compile it. So Play is dragging down any of the dependencies that we need. So the only thing I had to do to get both of these two live demos running is to download and install first SBT, because I wanted to do just a plain SBT project, and I also downloaded Play so that we could just jump into the console here and start our compiling. Now, okay, so we're just about done compiling here. We're going to run it. Turns out that there will be a little bit more compiling that we may see as we launch our web browser and go to localhost, and I'm going to go to the simplest thing you can. Let's start with Hello World, and we'll see, oops, oh, sorry, it's already compiled. So in this case, we can see Hello World, and if, just because we didn't see it before, we'll do it again. It's very fast. And now we'll go, let's go look at what a Play application looks like. There's some standard directories. There's an app directory that contains your controllers and views and models, and other things you want to put in there as well. There's another very important directory, the configurations directory, and we'll be looking at the routes file very soon. It also has an important role to play in Play. There's also logs for the running application. There's a project definition just like there was before for the SBT. There's a directory where you can put public assets like your JavaScript and style sheets, target directory for compiling, and a separate test directory. So let's start by looking at the routes file. Play is a model view controller framework, and so one of the important things you need to do is you need to map URLs into function calls, or into controllers is what you would normally think of this as. And in this case, we're actually mapping right down into a function or a method within an object here. And let's go look at Hello World. We're actually going to start not at the top, but we're going to proceed from simpler to more complex. So let's look at what's in Hello World. We'll go down into our controllers and into our application class here. It's actually an object that extends controller. All of the controllers in the Play Web Framework are like that. And this very first one shows just how simple it is to do web programming in Scala. Let's just add to this, and I'll show you the hit refresh workflow. How it is, and we'll just add, and also how we can mix in Java. So new Java util date. I'll hit save. We'll go back to our web page, and you'll see this. It's compiling in the background, and you can see how quick it is. We can mix Java. We can just hit refresh. We're not not having to step out of the application at all. Okay, so next level of complexity, what if we want to work with request parameters? Let's look at what that takes. Well, it turns out that these actions, right, we saw that Hello World was actually an action, right? It picks up functionality from that. Is actually a higher order function. One of the things it takes is it's being supplied a request. So now by calling it out in this form, we're actually supplying a function literal here. And this time we're going to say OK. Right, here's your name, and we're going to pull out from the request string. We're going to pull out from the request object. We're going to pull out a query string QP. And if it's not there, because this thing returns an option, which is a great feature of a lot of the APIs in the Play framework and something Scala supports. An option is something that can either have something in it or none or nothing. And so by returning an option, this API is forcing us to deal with the fact that there may have been nothing there. So rather, the alternative that you see in Java all the time is having to check for null. Well, using the option object lets the API creator and the consumer communicate more explicitly. And in this case, you have to deal with the fact that it might be null, and that's what this get or else is about. And in a way, it shows how the sort of general pattern that we'll see later on when we look at JSON about how you deal with error handling in a functional way. So here we're saying get or else. If they haven't given us any query parameters, we'll respond back with something reasonable. So now let's go ahead and try our echo. And we'll begin with nothing. And there's our use of the option object. And now we'll say, give it a query parameter, and something entirely new. And you can see how that works as well. So that's dealing with query parameters. Well, what if we wanted to do more? What if we wanted to pull some elements out of our route? Well, that's easy enough to do as well. I've jumped right ahead. There's another syntax that I won't go into here that's very easy, that allows you to very easily pull out elements of a URL that you can use in a REST API, REST-like API, so that you can get the different elements of the resource you're after. In this case, I'm just grabbing everything that's after this initial proxy get, and I'm going to show you how easy it is to build a web service, or to use, in this case, we're going to use a website as though it was a web service, because we're going to pick everything after this proxy get, and we're going to go retrieve it from the website. And this little function lets us demonstrate how easy it is to do asynchronous things, and this is the reactive web framework. It also shows this web service object and how easy it is to use it to go get a resource. And here it's the URL to proxy, just passed in as an argument. We'll get it. Again, we're applying our map, very general function. And this time we're going to, from the response, we're going to get the content type. If there was no content type specified, well, we'll use text plain, a reasonable thing to do. And then we're going to just tell OK that here's the response body, and by the way, here's the content type you should apply to it. So now let's go try our little proxy service here. Proxy, and let's start with Tumblr. So here you can see it grabbing information from Tumblr just as though I had hit the site directly, right? So this little proxy object we could use for all sorts of interesting things, but really it's the point is just to illustrate how easy it is to do asynchronous things with the Play web framework and with Scala. So we've tried a couple websites here. We saw Tumblr, and here's Yahoo. But let's show, and you saw how well those worked. Everything's great. Let's try Google, because it starts to show some of the limitations of what I've done. I've done something simple. I'm not following redirects. I'm not doing anything fancy. And in this case, when you go to, I saw this and I went to look behind the covers to see, and this is a very simple HTML page. You wouldn't think there was that much going on, but it turns out there's a lot more going on than meets the eye. And so it's not that surprising that my very simple solution for doing a proxy object perhaps ran into some problems because of some of the things that Google is actually doing behind the scenes. Alright, one more level of complexity here. Let's go and look at what it takes to deal with JSON. JSON's a very important capability showing up all over the place in web applications these days, and the Play web framework lets you deal with JSON in a variety of ways. I've for the sake of this particular demo, done a couple things. I've written a little converter here that uses Scala's parser combinations. Sorry, stumbling on the words here. Collection of parsers to assemble up an object from JSON into Scala. And the result is a tuple object. A tuple object is a collection of various types. And so in this case, our action object, turns out there are even more things you can do with action objects. You can do parsing in them. So this one is saying that it explicitly is expecting JSON, and what it's going to do with it is then validate it, so that will parse it into JSON, and this is going to validate the object, or the body that is received in the request, and ensure that it really is a tuple. That's what these parentheses are about, and that tuple is comprised of a string and a long. And if it is, well then we're going to apply this general map function here. The map function can take a regular function, as we've seen, as well as, in this case, it turns out this is a partial function, and it is expecting that tuple. So now we're doing it in a way. You can see a little bit of what the syntax is for the pattern matching as well. Those two things come together in this example, where we're matching on the name and the age, and we're saying if we've got that name and the age, well, let's pull them out, and we're going to turn them into arguments that we can use in here. We've got the name and the age here, and then we're just doing an OK thing. In fact, what we're doing is we're constructing a JSON object right here in line. Right, it's a JSON object with a status that's OK and a message that's hello name. And we'll go over the error handling in just a second. But to exercise this, let's go ahead and grab this line here, so we can use curl to illustrate our use of JSON. I'm going to go ahead and quit this SBT application, and I will use my curl right from the command line. So you can see us in our curl request constructing JSON. Right, here's the name, and here's a name is Toto, and the age is 32. And we're going to call our say hello, and we can see the results we got back. Right, status was okay, and here's the message. And just to show you, that we haven't lost our hit refresh workflow. Let's go ahead, modify it, do another curl, and see what we get for a result. And now, of course, we're compiling, right? And you can see it's just as fluid when working with JSON, working with web service development, as it is with working with the web development we saw before. The last thing I'll do, real quick, is we'll look at just briefly the view aspect of working with Play, and as I said, it's going to be a very brief introduction, and this time we're just going to hit, whoops, sorry about that, we're going to hit just the default index page. You see we've got a very rich sort of result here. Let's go see how that was constructed by going down into the views directory, and actually, but right before we do that, let's go back and look at our routes. You can see that when we get just the slash, right, we're going to go to application index. Application index says from the views, the HTML, pull out the one defined as index and pass it this argument. So it turns out that our views are also compiled down into Scala objects that have functions on them that we can call, and let's go look at that view. So we know we're going down into here, into index, and you can see where it's being passed a string. There's only one magic symbol in the view syntax, and that's the @ sign. The @ sign says what follows is Scala, and so it turns out we've got we've defined this thing to take a string, right, and we're going to apply that string down here. We're going to call another function, this play2l welcome, and that's where we got all the rich content that we saw here is all coming out of that one function, so you don't even see it in the template here. Let's go and look at what main was. It turns out that Scala or this Play web framework is a templating system, and so here you see the title coming in, you see content, so the whole thing's wrapped, right? We're either typing Scala when you see the @ sign, or we're typing HTML. So very simply mix the two. It ends up having a great, providing a great system for quickly doing all the simple things you want to do with a web application very easily and in a very natural way. So with that, let's go back to our presentation here and look at what's next. And what's next is really for you to try it. I've included links here. I'll mention that you can Google Prezi, P-R-E-Z-I, and Scala Overview for Java Dev, and you should be able to find this presentation, which will let you follow these links. So you can download SBT, install it. You'll need that actually if you want to play with any of the Twitter school, Scala school exercises. It will use SBT, so you may as well go ahead and get it. And then, of course, you can download that very simple Scala application that we were looking at when we started. Next tool you probably want to get, actually you'll probably need Git before you pull this out of GitHub. And if you want to fool with the Play web framework, you'll need to download Play, which you can get from here. And finally, you can then clone these Play Scala teaser so that you can get started with Play. I hope you've enjoyed the presentation, and hope you can follow these links and get started with Scala and Play yourself. Thank you very much.